Hi, and welcome to the video lecture for Day 4 of CIST 1400 Intro to Computer Programming in preparation for class on the 28th of January 2014. Today we're going to talk about algorithms and if statements. So, for the reading assignment, you'll probably want to read sections 3.1 through 3.5 of the title text by the time you come to class, and whether you read that before or after this lecture doesn't particularly matter. So the agenda for the day. We'll talk about algorithms and structures, and then about pseudocode and flowcharts, both very quickly. We'll talk about if statements, if-else statements, and we'll put those together to talk about the if-else and else-if statements. Finally, we'll talk about nested structures, and we'll do a really quick view of Boolean flags, as that's a technique that might come in handy. Alright, so to get started, let's talk about algorithms. Algorithms are basically step-by-step series of instructions. And these aren't limited to programming. A recipe, for example, might be an algorithm. An instruction book might be an algorithm. It's just a step-by-step series of instructions that tells you what to do, and then if you have to make any decisions, how to make those decisions. Within the scope of this class, within the scope of CIST 1400, we create algorithms in the Java programming language using one or more program structures. And these program structures are as follows. We have the procedural, which is step-by-step, that does line 1, then line 2, then line 3, then line 4. And that's the one we've been using already. That's the one that we sort of use by default. We have the control structure, which is if statements and switch statements. And we've seen if statements just a little bit already, but we'll spend a lot more time with them here in a bit. Then we have the repetition structure, which we'll talk about after we're done with the first quiz, which is loops, things like while, do while, and for loops. And loops are, with these three structures, we can write any piece of software we want. These aren't the only three structures. There are a couple of different programming paradigms that we'll get a very, very brief glimpse of over the course of today. But with these three structures, you can write every single piece of software. It's just, sometimes there are easier structures to use, and we'll talk about that in a bit. So when we're planning out our algorithms, when we're planning out sort of the structure of our programs, there are two tools that are available to us so that we can plot out programs using our brains before we start the actual act of programming. A thing that often happens with novice programmers, they'll sit down and they'll think to themselves, all right, I think I'm going to need a loop, so I'll write a loop, and I think I'm going to need some if statements, so I'll write those too, and I think I might need a method, so I'm going to make one of those too. And then I'll start worrying about how I want to solve this problem. And that's generally a problematic way to solve things. Ideally, especially in this course, I'd like you to, as much as possible, do some planning with regard to how you start programming before you sit down. So I want to show you two techniques you can use to do that planning. One technique is pseudocode, which is a plain English-ish written explanation of how a program works. So for example, you might write down display intro message, ask the user for a name, store it into a string called name, display the menu for the user, prompt for choice, collect the choice from the user, and if that choice is valid, do that action, and if the choice isn't valid, show them the menu again. And then so on and so on. This is incidentally a solid way to use comments as signposts. Like it wouldn't be at all strange for us to write these as comments and then use them to structure our programs. That's sort of the power of pseudocode. Flowcharts are a graphical way of representing a program's structure and are particularly useful if you're thinking to yourself, gosh, this looks really complicated. I wonder if there's a simpler way to do that. Particularly if you think of yourself as a visual learner. Sometimes with a flowchart, you can see that what you've written is a giant mess, and then we can simplify and make things a little bit easier to build, a little bit easier to maintain, a little bit easier to work with. So with the flowchart, we have a couple of symbols. We actually have a whole bunch of symbols. These are the ones that you might find useful, and don't feel like you have to use any of these necessarily. Don't feel like you have to use all of these. When I'm making flowcharts on my own, the only ones that I use are the decision and the procedure. Really, I'll only use those two boxes for the most part. Method every once in a while, I'll probably never use the calculation, as that may as well go into the procedure. Procedure is like input-output stuff, or output stuff. And I'll usually not use the manual input box, as you may as well just do that with the procedure as well. Which is to say that you can find sort of your own idiomatic flowchart style. Then the way that we put this together is we start with our program start, if you choose to do that, and then you draw arrows showing how the program flow goes to the next item. And so it looks sort of like this. And so for a really, really simple program with the scanner, we might do, it might look at its outset something like this, where we can start the program, ask the user for a number, collect that integer and store it as x, and then output you entered x. And the thing that we would have to do then would be to make sure that, would be to look at this and say things like, oh gosh, if I'm going to collect an integer, I need a scanner. Now do I want to make the scanner before, or do I want to make the scanner after I collect the input before I collect the integer, or do I want to make the scanner right at the start? And with a lot of these things, it doesn't matter too much, but it is one of those things where we can look at our programs sort of graphically and kind of trace them backwards. So this is what we call teleological thinking, or backmapping, where you can say things so like you entered, and then we have this integer called x, which means that we have to collect the integer, like so, which then means that we have to make a scanner. So what we really should do is go back here and add another box, maybe right here or right there, showing exactly where a scanner might get made. This is flowcharts, and I'll show you flowcharts for some of the structures that we build as we go along, but not for all of them. Okay, so we'll talk real briefly about if statements. You've seen them already, but if statements consist of two parts. You've got a conditional, which is a Boolean expression. It's an expression that ultimately resolves to either a true or false. Then we have a block, and the block is the thing that we do if that condition is true. So here's an example of an if statement. If x mod 7 is equal to 0, system.println x is divisible by 7, then system.println huzzah. Our conditional is that part in green. We check to see if x is evenly divisible by 7. That is to say, we check to see if after dividing by 7 we have no remainder. And if that's the case, we go ahead and we execute this code block. So if this condition is true, we execute the code block. We output these things. If that condition isn't true, we skip down to the end of this block and we proceed from there. And here in a few minutes we'll talk about the else structure, which will let us have things happen if the condition isn't true. But for right now, if the condition isn't true, all you need to know is that it looks at this opening curly brace and then finds its matched partner and goes right after it. Okay, so that's the thing that you need to know right now. And so then the question, this is the if-else statement. What if we want one thing to happen if our conditional is true and another thing to happen if the conditional is false? And that's where we're going to be when we come back here in just a minute.